Okay, this is Algebra 2, and we're going to talk about some special functions. And so there are a couple different kinds that I want to talk about today, and we're going to start off with this first one. So let me move my screen up higher. Okay, and so you can see off to the right here, this graph. And really what we have is three pieces. We've got a piece here, we got a piece here, and we've got a piece here. And that's really what this is called. So because we have pieces, this is called a piecewise function. A piecewise function. All right? Piecewise. So you can see here we've got f of x off to the left, right here, right? And remember, you can always replace it with a y. And really what we have is these three pieces of equations. Well, the first one is in the form of y equals mx plus b. And this is linear. And I know it's a line. The second one here, this purple one, is a negative x squared plus 1. It's quadratic. Quadratic. Right? And we'll work on identifying those later. And then this third one here, this orange one, is also y equals mx plus b, and it's also linear. So the first part is the function. Now here's the key. This second part lists the domain. So from the if over is the listed domain for each one. Okay? And then all, in this case, three of them, there could be four, there could only be two, there could be five. Piecewise is putting a bunch of functions together. Okay? So this one has three. And so we only show the portion of the function over what's given as the domain. So let me try to explain. So our first one is negative x minus 2 if x is less than or equal to negative 1. Okay, well, let's think about just graphing this, just normal. All right, y equals mx plus b, right, is what you're thinking. You always graph the y-intercept first at negative 2. And then what is my slope? A negative 1. Down 1 to the right 1. Down 1 to the right 1. And if I were to graph it, it would be this line. Okay, well, that's the function for all domains. But notice it says only use values of x from negative 1 and lower. So what happens then is I must go to negative 1 on my x-axis and understand that I only use values from negative 1 down that way. And what does that cause me to do? It causes me to erase, let me grab my eraser, causes me to erase all these values and only leave the part of the line where the x is negative 1 and lower. I hope that makes sense. The second one is a parabola. We're going to deal a lot more with parabolas later on. If I were to graph that, the full thing, it would look like this. Here, I'd make it solid. It would look like that, and it would look like that. It's parabola. And that would be the normal, just the whole parabola. But this one again says, no. Only use a domain where negative 1 is less than x, and x is less than or equal to 2. Now, if you're thinking like conjunction, how would that look as a conjunction? That would have a circle over the negative 1 and a line over to the 2 with a dot on the 2. These are the only places we want the curve to exist. So again, I'm going to grab my eraser, and when I erase the parts anything lower than negative 1, notice I had the circle there because negative 1 is not included, and only the part of the curve up to including 2. That's the second part. All right, the third one, again, y equals mx plus b. There is no y-intercept, but if I was graphing, it would be 0. The y-intercept is 0, so I would put a point at 0, right? And then the slope is 1/2, so I'd go up 1 and to the right 2, and I'd put a dot, and I would draw my line, something like that, right? But again, the domain says only when values are greater than 2. So I only want these x values, an x value of greater than 2. So again, I must erase any parts of the line that do not have an x value of less than 2. And that gives me that part of the function. So a piecewise function. All three parts are the one function together. All right? So let's go back and fill in the other two blanks then. A piecewise function is one whose value is defined by different expressions for various functions for various intervals, intervals of its domain. Okay? All right, so all those pieces gives me the blue piece from the blue, the purple piece from the purple, and the orange piece from the orange. All right. Now, we want to find out now the domain of what do we get as far as possible x values when we put the blue piece together with the purple piece together with the orange piece. Okay. So I'm going to do the domain right on the x-axis. I always like to go lowest to highest x value. Well, what's my lowest x value? Well, notice this blue one keeps going on forever. It goes up, but it goes forever left. So because it goes forever left, I know I have this part of the domain. Now I'm working backwards. It's anywhere where I see the function. Now when you get to -1, you may think I don't have it, but I do have it because of that. So -1's included. Now I have purple everywhere, purple everywhere. Okay, when I get here, wait, there's a circle there, but you know what? There's a dot there, so that's still included. And notice that the orange goes up and to the right forever. So what does that represent? All the real values. So the set of all x's such that x equals all the real numbers. Now that's in set builder notation, right? You learn that in geometry. It's read the set of all x's, the vertical line is read such that. So the set of all x's such that x equals all the real numbers. Now, there's also a way to write the domain as an interval. And the higher up you get in your math, the more you'll use intervals. So I'm going to teach you how to do that right now. You always want to start with the lowest value possible. Okay, this goes to -infinity, comma, highest possible value, positive infinity. Now we use two symbols. We use either a parentheses or a bracket. Use a parentheses when the value is not the specific value, and use a bracket when it includes that specific value. Infinities don't have a specific value, so they're always parentheses. So that's the interval. Now I'll show you the other way here when we do the range. Okay, you got to remember the range are the y values. So look at the piecewise function. What's the lowest possible y value? And I hope you see it's at -3, right? Now, as I head up, I still have function with y values, function with y values, function with y values, function with y values. Here I got, 3 different possibilities, but I got y values, And because the blue, just one would be enough, but also the orange go up forever, I have every y value continuing up in that direction. So what inequality is that? That's y greater than or equal to -3. So again, if we were to read set builder notation, set of all y's such that y is greater than or equal to -3. Now how do you do this in an interval? Again, you always start with the lowest value, that's -3. You end with the highest value, that's positive infinity. I already told you, use always parentheses with your infinity. Now the -3 is included, correct? Because of the dot. Therefore we use a bracket. If it were an open circle at the -3, I would use a parentheses. So now we know. All right, so two different ways of saying the same thing. Set builder notation or inequality form and interval form. Domain and range. All right? piecewise functions. I think they're quite interesting. So let's look at another one. So here's another one, piecewise function, and we want to give the domain and the range. All right, so feel free at any time to pause the video and try to think it through yourself if you want to see if you're understanding. So again, domain, I'm looking at x values. So I'm thinking x values. So I'm going all the way left till I no longer see the function when I go left. And I hope you agree right there is the furthest left. And I use a circle because that's a circle, right? And I'm just going to work my way now toward the highest value. I got function, I got function, I got function, I got function, all the way till I get to here, and I got another dot. Okay, that's the interval. Do you remember how to say that as a conjunction? All right, so let me refresh your memory. I'm not going to do the set builder notation. I'm just going to do it as an inequality. Right? You always write the lowest value, -4. Remember, your inequality symbols always point left. Do I use a less than or equal to? And hopefully you're thinking less than, right, because of the circle. And then your x, right? So -4 is less than x. And what do I use next? Less than or equal to? The dot says less than or equal to, and then I put 6. Okay, that's inequality form. If I put it set of all x's such that, and then that with another brace, it would be set builder notation. All right, how would I write this as an interval? So again, my lowest value, comma, my highest value. The lowest value is not included, parentheses. The highest value is included, bracket, right, as an interval. All right, got our domain done. Let's do our range. Look at the function. What's the lowest y value? And I hope you agree it's -2. Now, as I go up, I notice over here I got this hole. And it's sometimes possible to have that hole in the middle. We don't have a hole in the middle on this one because if you go the other way, we got a solid line. But it is possible to have a hole in the middle, in which case you got to deal with that. I think one of the homeworks deals with that. But this goes all the way up to here, and look, that point's included. That's where it ends. That's the highest value. All right? So what is this? This is -2 is less than or equal to y is less than or equal to 5. Writing that as an interval, lowest, highest. Lowest is included bracket, highest is included bracket. Hope that makes sense, right? So interval form. Domain and range. It is an important aspect of this chapter. We're going to use it more and more and more throughout the course. So now's the time to really get a handle on figuring out domain and ranges. You're looking for where the function appears. Domain for the given x values and range for the given y values. All right, I hope that helps with doing it, marking the axis. All right, let's graph this piecewise function and state its domain and range. All right. So first off, remember, we have 3 different functions here, blue, a green, and a red. So the blue one, be careful here. Students oftentimes mess this up. So just to be clear, what we're graphing for the y is y equals 4. All right, that is a horizontal line. Now, you might not want to do this yet. At 4. However, see, I can erase. If you did it in pen, you can't, right? Y equals 4. But we have to also take into account over what domain. And this says to include from -1 down. So I can only do this part of the line, and I got to get rid of, whoops, I erased too much because it was too big, but that's okay. Put it back on there. So do you agree I only have the part of the line from -1 to all the to -infinity on the domain? So that's the only part I get for that first blue part. Second one, y equals x minus 2. Clearly, again, the y-intercept is -2. We're going to graph that first. I got a slope of 1. So I'm up 1 to the right 1, I'm up 1 to the right 1, etc., etc. Now again, before I just draw this line, I better think about my domain. The domain says -1 is included. Okay, so I know I go to -1. And because the -1 is included, I'm going to put a dot there, right? And then the domain says less than or equal to 3. So I got to end at 3, but it does include the 3. So now I'm just going to keep going along my line until I hit the 3 on the domain, right? You follow? So see how my domain goes from -1 on the x-axis to +3 on the x-axis? Okay, that's the green part. By the way, these can overlap. These don't, but they could. All right, and the last line is y equals -x plus 4. Y equals -x plus 4. Okay, so again, the y-intercept is 4. Just going to put a dot there because this is where I'm out of the domain already. Down 1 into the right one, down 1 into the right one, down 1 into the right one, down 1 into the right one. But I got to be careful. I start at -3, right? And I don't include -3. So I'm seeing this line. So I understand I start there. And again, I keep going down 1 into the right one. And it goes forever like that. And I hope that makes sense. Okay, we've graphed the piecewise function. Now, what's the domain and what's the range? So you got to look. Going left, how far does this function go? Forever. Every point in between is included, and forever to the right. So if I just do an inequality, it's all the real numbers. If I do it as an interval, parentheses always when you use infinity. Parentheses, -infinity, comma, infinity parentheses. Okay, the range, be careful, a little bit different. What is the lowest y value? -3, and it's included. Less than or equal to. We're doing a range, we're doing y's. Okay, now watch. I'll do it here. I got to use green. Here, I got function, I got function, I got function, I got function. Because of the green dot on top, I got function. That's it. Y less than or equal to, -3 less than or equal to y, less than or equal to 1. But notice, I also have this. How do you say that? It's got to be like a disjunction. So how do we say all this also the part I circled? It's by using the word or. If you use the word and, technically you're not correct, all right? It's the word or y equals 4. Now we've got everything. You say, Mr. Scarfy, how do you do that in an interval? The answer is you don't. Okay, you don't. You'd have to just say interval, -3, comma, 1 interval, and then you'd also have to say or y equals 4. All right? Tricky one. But notice how we had to care for that gap. Because again, notice in here, there is no function. There's no range in those values in between 1 and 4. Nor are there any range up there, nor is there any range down there. Piecewise functions. Okay? All right, hope that helps. What else? Absolute value. All right, we dealt some last year with absolute value. You never want to forget the shape of an absolute value. So whenever you see absolute value, and again, this 2 vertical lines, right? Absolute value. Whenever you see absolute value, you got to think, okay, I've got absolute value. All right, you got to think, I got absolute value. It's a V shape. You can't forget that. You got to remember that. All right, graph f of x equals the absolute value of x, and then graph f of x equals 1 times quantity x minus 2 plus 1. All right, so let me remind you of the format. All right, I'm not going to do this one here for time's sake, but let me remind you of the format. F of x or y equals m, the slope, x minus h, x minus 8. All right, what happens when all of a sudden your computer starts playing another video? All right, sorry about that. Okay, so x minus h. All right, been having some trouble with the video. Hopefully we're back and things are normal. I hope. I don't know. We'll see. All right, anyhow. So the vertex, this is really key. The vertex of the absolute value has coordinates of h, k. Okay, so if you look at this, we know the vertex of this thing is at 2, 1. All right, that's important information. So we're going to plot that point at 2, 1. And because I know the slope is 1, I know to go up 1 and to the right 1 and put a point. I also know to go up 1 and to the left 1 because I know it's a V shape. And there's my graph. Now, if you can do it that way, it's best. Start with your vertex and use the slope. If it would have been a negative 1, I would go down 1 to the right 1, down 1 to the left 1, and the V would go upside down. Right? But if not, you're going to have to use an XY chart. Now, you're going to have to be careful with an XY chart because if you use an XY chart, if you do 0, you're going to get this point up here. Right? So watch. If you do 0, you're getting that point up there. When you do 1, you're going to get the point here. And when you do 2, you're going to get the point there. And most students will just draw the line right there. They won't even realize that it's a V shape and, okay, we haven't got to the other part of the V. So you can use an XY chart, right? Anything can be graphed using an XY chart. But boy, so much the better if you understand that absolute value is a V shape. Okay, so again, oh, I got the template down there. All right, great. I think I did it in class the other day as well. But such is the case, right? So in this one, let's go backwards now. We're going to write the equation of this absolute value function. All right, so I need the vertex. So -1 and -2. So h is -1, k is -2, and what's the slope? Up 1 to the right 1. All right, slope is 1, so we just leave it. So y equals, here I'll put it in just for emphasis, times x minus, okay, now, and we got the absolute value there. Hey, be careful, minus a minus is a plus. So we end up with y equals the absolute value of x plus 1 minus 2. And we just wrote the equation of the absolute value function. Make sense? All right, I hope so. Everything comes out of the vertex, right? H and K, and you're following the template, and we're able to write the equation. All right, what else we got here in line? All right, the greatest integer function. Students can tend to struggle a little bit with this greatest integer function. Okay, so notice the bracketing. That's what tells you it's the greatest integer function. But here's the trick. You have to be careful because it's the greatest integer, the biggest integer less than or equal to the number you're talking about. For example, if I said 7.2, the greatest integer is 7, that's less than, but it's the biggest less than number. That's an integer. If I said 9.9, the biggest integer that's less than 9.9 is 9. If I said -2.4, the biggest integer that's less than -2 is -3. If I said -7, the biggest integer that's less than or equal to -7 is -7. Got the idea? If I said 3.5, I got to go smaller, but the biggest integer that's smaller, and that's a 3. Okay, I hope that makes sense to you, and that's what we're doing. Okay, so we have to look at the domain. This is the domain right here. I can only use values of x that go a little bit bigger than -3 and a little bit smaller than 4. Okay, so a little bit bigger than -3. How about -2.9? -2.9. What is the integer that's just that is smaller than negative 2.9, but it's the biggest integer that's smaller. And I hope you think it's negative 3. Okay, it is. If I go negative 2.7, it would still be negative 3. If I go negative 2.1, it's still negative 3. When I go negative 2, now it's negative 2. When I go negative 1.5, it's negative 2. When I go negative 0.9, it's negative 1. How do you graph that? All right, watch. This is interesting. They take steps. Okay, so my domain can't quite reach negative 3, so I got to use a circle. And between negative 3 to negative 2, but not including negative 2, the answer is negative 3. But then when I get to negative 2, dot, the answer's negative 2 until I get to negative 1, which again circle, because a negative 1 is a negative 1. Until I get to 0, and the 0 is a 0. Until I get to 1, because the 1 is a 1. 1.1 is a 1, 1.5 is a 1, 1.7 is a 1, until I get to 2, because a 2 is a 2. A 2.1 is a 2, a 2.7 is a 2, a 2.9 is a 2, but a 3 is a 3. And I get a 3.1 is a 3, a 3.5 is a 3, and I don't get to 4 because of the domain. There's the function. Hey, that's tricky, I know. But if you work at it, you can get it, all right? The greatest integer function. All right, so piecewise, absolute value, and greatest integer function.